Welcome to Brain Vision.
All right, so we're modeling a person lifting a dumbbell as having like their humerus. This is probably a little bit too long for a humerus. Like there's the humerus with the biceps attached to the forearm, which is this horizontal line, and this is our elbow joint. This is our forearm here, and we're told the biceps are attached at a distance of 4 centimeters from the elbow joint. We're told the forearm has a mass of 2 kilograms that acts about 10 centimeters from the elbow joint. So this is 0.1 meters. And if it has a mass of 2 kilograms, that means the weight is 19.6 newtons. And then lastly, the person is holding a dumbbell at the edge of the forearm, which is a total distance of 30 centimeters away from the elbow joint. And it has a mass of, or weight of 20 pounds, which is basically a mass of 9.09 kilograms. So that comes out to be like 89.08. Let's see, 89.08 newtons. And the biceps act, we're also told, at an angle of 110 degrees relative to the forearm. Hopefully this is clear enough. And we want to calculate the force of the bicep on the forearm. So we have a couple of torques to consider. We're going to have the torque of the biceps themselves, we'll call it TF, and that's the force the biceps exert times their distance to our pivot point, which we'll take to be the elbow joint. So this distance is 0.04 meters times the sine of 110 degrees. Then the torque due to the forearm, which is just going to be the weight of the forearm with a negative sign, so 19.6 newtons, times its distance from the pivot point, which we're told is 10 centimeters. And then the torque from the dumbbell is going to be the weight of the dumbbell times its distance from the pivot point is 30 centimeters. And so in equilibrium, all of these torques add up to 0. So we'll have the torque from the biceps plus the torque from the forearm plus the torque from the dumbbell. This is all equal to 0. So we have F times 0.04 meters times the sine of 110 minus 1.96 Newton meters minus 26.72 Newton meters. I already went ahead and did the multiplication on these two terms. This is equal to 0. And so we can see F is going to be 1.96 Newton meters plus 26.72 Newton meters divided by 0.04 meters times the sine of 110. And so if we plug in all those numbers, we should get something like 763.14 newtons. So that's our bicep force. And then next we want to know what's the force in the elbow joint. So this is really just going to be what's the horizontal component of all of these forces added together. Well, the forearm force and the dumbbell force are both vertical, so there are no horizontal components. So the only component we have to consider here is like the bicep force times the cosine of the angle it acts at. And so if we do that, we should get something like negative 261 newtons. Because the bicep is acting at an angle, so it has, if we draw like a little diagram of this, this is our 110 degree angle. Some part of the bicep force is going this way. The other part is going upwards. And so the part along the elbow or towards the elbow is negative 261 newtons.